The question whether life exists outside of our planet has been around since the antique. The so-called SETI Institute is keeping an eye out for the proof of life on other interstellar objects. But as you probably know, there are billions and billions of habitable extraterrestrial planets in the universe, and space is extremely vast. This means that the chance of finding another intelligent species is rather small. Unfortunately, pictures like these are rather unlikely to be seen in our lifetime. As of right now, our technology is not advanced enough to be able to reach a fracture of the light speed, let alone when you'd have to transport people. Imagine our Earth would end. How would you save our generation and find a new habitable planet? There are proposals to use generation ships, for example, to colonize other planets. Such a world ship, a hypothetical interstellar spacecraft carrying vast populations, would take several years to transport its passengers to another planetary system if it were moving at less than 1% the speed of light. An extremely high number of people would be needed for both the passengers' health and their capacity to pass on their knowledge and talents to the future generations while aboard the ship. To make it through 150 years of interstellar travel in good health, up to 44,000 people would be required. Wouldn't it make more sense to use a planet like a space taxi to travel to your destination? There are a lot of advantages of using, for example, a free-floating planet in contrast to a spacecraft. The available space and the availability of liquid water for space radiation shielding are just two advantages. So why would extraterrestrial intelligent life not travel through space like this? This process of migration would most definitely yield technosignatures, which we could detect. Technosignatures is any measurable property or effect that provides scientific evidence of past or present technology. The search for these technosignatures produced by migrating extraterrestrial civilizations can be described as the search for migrating extraterrestrial intelligence, short SMEDI.
And with this short introduction, I welcome you to my presentation about migrating extraterrestrial civilization and interstellar colonization, and its implications for SETI and SETA. First up to the agenda. At first, I'm going to talk about the search for migrating extraterrestrial intelligence and where we should search for them and why. After that, I'm going to talk about free-floating planets used as stellar migration, ways of reaching those free-floating planets, and how rare they are in our galaxy. After that, I'm going to talk about the space colonization and possible daughter civilizations which could occur. And then technosignatures, which occur when using free-floating planets as stellar migration, and the strategies for the search for technosignatures, so where we should search for them and where they could occur. Last but not least, I'm going to conclude the article and present my takeaways. So the first question which arises is where we should search for intelligent life forms. It's proposed to search for extraterrestrial intelligence mainly on planetary systems with main sequence host stars, preferably G and K type stars. The thought behind this is because they have a very long and stable habitable zone. Therefore, living organisms could evolve longer on those planets with such a habitable zone, producing a much more intelligent civilization, and this civilization would probably produce observable technosignatures. However, like you see in our civilization, we spend a lot of time in cyberspace and not really looking for technosignatures for a long time. So this could be the case for other civilization as well, that they don't really produce technosignatures at all because they spend all their time online. Another fact, however, is when they get much more intelligent, their technosignatures could become less detectable. There's even a classification. For example, class 3 civilization can fully integrate with their environment, making it possible to distinguish their technologies from natural phenomena. So yeah, like I said, those advanced extraterrestrial civilization allow less noticeable technosignatures. However, when, for example, a destructive cosmic event occurs, you'd have to move your planet, and moving planets would cause observable technosignatures for sure, even for very advanced civilizations. Such threats could be, for example, a main sequence star turning into a red giant star, which would lead to the civilization having to move to the outer region of the habitable zone, because the habitable zone moves outwards because of that transformation. And this would lead to, for example, communication technosignatures or atmospheric technosignatures. There are different ways of migrating. I'm going to mainly talk about free-floating planets, because in my article it's about free-floating planets. They propose two other migration ways. One is using stellar engines, and the other one is using close flybys of stars. So that when a star flies by your planetary system, you can just hop on it and travel to the next solar system. So with all of this, the article says that SETI should also include SMETI, so looking for technosignature inside of planetary systems and outside of the civilization's planetary system. They should also look for intelligent machines which could be sent to the outer region of their planetary system. Free-floating planets as interstellar migration. Biological species, post-biological species, and their technologies would become cosmic hitchhikers when traveling on free-floating planets. Free-floating planets have a lot of advantages compared to, for example, spacecraft. On free-floating planets, there is constant gravity, like on Earth, so no zero gravity, like in spacecraft. There are large amounts of resources on free-floating planets, which you could use for repairing stuff or manufacturing. Obviously, there is way more space on free-floating planets than on a spacecraft, so you could move larger population of people. Free floating planets could have surface and subsurface oceans, which could provide water for a consumable resource, but also for space radiation shielding, which is um, ex- extremely important. Um, if nuclear fusion could be controlled by humankind and used as a source of energy, then it would also become a source of energy for interstellar travelers on free floating planets. The first way of reaching the free floating planets is when the civilization uses a free floating planet which passes by their home world really close. 70,000 years ago, a star called W0720 passed our solar system really close. And studies predict that there may be billions of free-floating planets. Therefore, some free-floating planets may pass near the Oort cloud of planetary systems or through the Oort clouds as well, as stars sometimes do, like W0720 showed. And if the number of free-floating planets is greater than the number of stars in our galaxy, then the flybys of free-floating planets is also more possible than of stars. And how would we reach those free-floating planets that pass by in the Oort cloud? It could be that advanced civilization civilized the whole planetary system, so they have civilization also outside in the outer solar system, so they could just jump on the free floating planet. It could also be that you would fly to the Oort cloud with a spacecraft and then use astronomical engineering, for example, a sail or a propulsion system to reach that free floating planet. To the second scenario. The second scenario is using free floating planets steered towards extraterrestrial civilizations' homeworlds by means of astronomical engineering. This scenario is similar to the first one, but here astronomical engineering is used to pull the free floating planet towards your solar system in order to create some kind of artificial flyby of a free floating planet. The third scenario is using free floating planets ejected from planetary system by means of astronomical engineering. Here you would, for example, take an object like Setna and put a propulsion system or a sail on Setna in order so that Setna gets ejected out of the orbit. You wouldn't use a planet that is close to the sun or very big, because then you would change the orbits of the other planets. So here you change the orbit in order to eject the planet out of the planetary system, or in here the object out of the planetary system. And here the object will itself be the free floating planet. The last scenario is when Oort cloud objects get ejected out of the planetary system because of the host post main sequence stars. Extraterrestrial civilizations may write Oort cloud objects of their planetary system, which become free-floating planets after being ejected by their host stars during the red giant branch and the asymptotic giant branch evolution. In all of those scenarios, free-floating planets may not serve as permanent means of escape from existential threats. Because of the decrease of heat production in the interior, such planets eventually fail to sustain liquid water. That's why free-floating planets should really only be used as means of transport. Now, how common or how rare are free-floating planets? To detect free-floating planets with low surface temperature, you use gravitational microlensing. For free-floating planets with hot surface temperature, you use infrared imaging. Free-floating planets may originally form around a host star and in multiple star systems, and then they may be scattered away. Free-floating planets may form in isolation through direct collapse of clouds of gas and dust. According to simulations of terrestrial planet formation around a solar-type star, about 2.5 terrestrial mass planets per star become free-floating planets after they are ejected during the planet formation process. So this means they are rather common, but it is rather hard to observe them. And now to the space colonization and the number of daughter civilizations. When an advanced civilization established colonies in their planetary system, its colonies become autonomous civilizations. Those autonomous civilizations differ a lot from their parent civilization. The reason for that is socio-economic reason, and the other reason is that it differs a lot. The environment differs a lot from each planet, so every daughter civilization will be different. And now to the techno-signatures caused by free-floating planets and their civilization. Because free-floating planets are hard to detect, techno-signatures produced on them can be easily mistaken as techno-signatures originated in planetary systems or group of stars. This may occur when they are close to each other. Later, the techno-signature may not be detectable anymore because the free-floating planet moved away. That is why the search for free-floating planets is recommended in the regions where unexplained emissions of electromagnetic radiation or unusual cosmic phenomena are detected. A second techno-signature is the emission of electromagnetic radiation detected relatively close to free-floating planets. When you travel with free-floating planets and you reach your planetary system, but your planetary system is faster or slower than you need a sail to decrease or increase your velocity to adjust to that planetary system. And this sail would produce techno-signatures because the interaction of the interstellar medium with that magnetic sail. Another techno-signature is the unusual infrared emission. This occurs when waste heat is generated by the civilization's technology, and we can observe this through mid-infrared wavelengths. Another technosignature is similar technosignatures produced in more than one planetary system. This means when in one planetary system, multiple planets have the same environment and same atmospheric composition and surface temperature, it could mean that a civilization terraformed this planet so that all of them are the same. And SETI is going to include this into their research to look for similar technosignatures so you could determine that it is terraforming. And now to the strategy for the search for technosignatures. Where should you find or where should you search for technosignatures? The best place to search for technosignatures is the Oort cloud of asymptotic giant branch stars or red giant branch stars. They can eject objects out of their Oort cloud, and like I said, when talking about the ways of reaching free-floating planets, you'd have to go through the Oort cloud with astronomical engineering. Yeah, that would lead to observable technosignatures. Another strategy is to look for planetary systems with gravitationally captured free-floating planets, because maybe advanced civilization used those free-floating planets to get to their desired solar system, and that's why that free-floating planet could host technosignatures on him. And now to the conclusion. I think that the article is really interesting. It gives important insights about the search for migrating extraterrestrial life and the technosignatures. In my opinion, it is also extremely important to include SMEDI into SETI, because it is as possible to find technosignatures as other signatures. And the thought that we're probably not alone in the universe is a little bit frightening for me, but I think that it is a long journey to find technosignatures, but it will be an extremely interesting topic in the future. And with that, I'm thanking you for your attention, and please leave any questions or suggestions down below. Thank you.